Thank you for the question. I think it's really important, and what we have now seen from a number of different studies from the group at Memorial Sloan Kettering and other places is that microbial diversity is a predictor of transplant outcome for allogeneic transplant recipients, and that has been shown most convincingly in recipients of unmodified stem cell products. But importantly, we've also seen that it means something in the patients undergoing autologous transplant, so those undergoing, for example, melphalan autograft for myeloma or beam autograft for lymphoma. And so I think that we've now shown across a number of different types of transplant that it is really important. That early diversity loss seems to set patients up for longer term complications. So for the second part of your question, what are the most significant factors contributing to loss of diversity? There's a number of them. Partly, patients arrive to transplant with a damaged microbiome from their previous treatments and previous antibiotics, and then as they go through the transplant conditioning process, we also we damage the microbiome further, and then they enter a period where they have gut damage and profound neutropenia. They often get further antibiotics, and they are really having a very altered diet through that time. And so it's really a combination of the antibiotic exposure and the dietary change, and I think that makes the biggest difference. And I think we're in a really exciting time in the field with lots of different trials going on, and I think focusing on giving the least damaging antibiotics we can, and so often that means things like using cefepime as first line instead of piperacillin tazobactam or carbapenem, for example, when our patients get neutropenic fevers. So I think that's one component, and there is a randomized study comparing those two outcomes that has, I think, just finished up, and we should be able to know the results of that shortly. I think further, in terms of approaches to actually change the gut microbiome, there's been a recent set of data released by a company called Series, and they've had a product in trial that is a defined consortium of bacteria that's been given to transplant patients early in the transplant course, and the results of that are quite promising, showing that there were fewer infections in the patients who had the bacterial consortium given to them. There wasn't sufficient power to demonstrate an improvement in GVHD, but hopefully as they study more patients, then we see further benefits. So I think strategies like defined consortia will be really valuable, because that's something that could be applied all over the world as a defined product. Strategies like fecal microbiome transplantation, that is being discussed actively at this meeting, I think can be very useful but difficult to really roll out as a worldwide strategy that we could use everywhere, because we have to define a donor to do that. I think that single bacteria replacement is another strategy that people are trying, and I think that that will be very challenging, because the microbial community is a complex network and there are trillions of those bacteria. I think just adding in one specific bacteria type is definitely there's a possibility that that's a successful approach, but I think that that's going to be difficult because there's such a complex community there. I think, of course, we could run 16S sequencing or shotgun metagenomic sequencing, but that takes a little while to come back and is challenging to interpret, so I don't think that that's what we need to do in clinical practice. I think a lot of the time in the transplant population, we know that the microbiome has been damaged, and so we could proceed with treatments or repair strategies essentially for all of our patients. I don't know that we always need to prove damage first. When people have wanted to do that in clinical trials, they have, for example, looked at a loss of some particular taxa like Clostridia and used that to say, yes, the microbiome is definitely damaged, we should repair it. So that's a strategy in clinical trials, but I think in general, the transplant population, microbial damage is so universal that we can probably proceed as if that has been the case without needing to use specific tests, especially when people have been exposed to broad spectrum antibiotics.